This is a good to know topic. This will help us read, understand, visualize mathematical topics, expressions, equations better, and it will help us like the topic better, right? So let's start off with the representation of the function. The very first form is your set builder form. So how do you read it? F of x is equal to set of all x such that x is equal to 2a plus 3, and set A is made up of -1, -2, 0, 1 and 2. So how does this help? This will help us indicate exclusively what are the independent variables, right? In this case, that's our independent variable. Post this vertical bar, right? Also we can use this, I forgot this 2 dots, I forgot the name of that. So we can use that, right? Post that whatever this conditional bar is, post that whatever we write, it is about the condition. Okay, so when I tell condition, the condition that the variable should satisfy to be part of the set. Is it not? We have seen this. This condition is to do with condition so the condition that the variable should satisfy to be part of the set, right? So where exactly is this used? Generally it's used to describe graph or to broadly talk about the function. Basically it's used in documentation and stuff, right? Next is your functional notation. So it's quite simple. F of x is equal to 2x plus 3. This you guys have been seeing from past 3-4 years. So functional notation is commonly used in mathematics, physics, engineering to represent function, right? When you work out numericals and so on and so forth. Third thing is function mapping notation. So this helps us talk about the domain, codomain, right, in its representation itself. Okay, for example, over here, how do you read it? And that also I'll be talking about it now. So this particular function, the function f, it maps x to 2x plus 3. Okay, right? So here this function, it maps set A to set B. So here I have indicated how to read it so that you guys don't miss. So here we have to read it as function f maps set x to 2x plus 3. So it helps us in notifying or talking about the domain and codomain, right? So many branches of mathematics and computer science, they make use of this to formally define and describe functions and the structures. Okay, see, again, I'm just trying to give you guys a gist of why we are doing it and where all do we use it, right? You need to be aware of it. Okay, so mapping diagram or function map diagram, you guys have known, you guys are familiar with this. This is what I'm talking about. So the same function f of x, here the input are -2, -1, 0 for this particular example, that is, right? And the output would be -4, 3, how much guys? -1, this is 1, and this will be 3, and this will be 5, and this will be 7. It's an arithmetic progression, right? And then you indicate what value has been mapped to what, something like this. Is it not? Okay, so this is how we can represent. Actually I can give a better example for this. F maps set A to, say, this is set of natural numbers, no, integers, sorry, right? This particular function for this particular example we can indicate in this manner. Function f maps set A to what? To z, integers. Okay, the next one is tabulated form. Quite simple. You make a table. Basically you will write the independent variable, then the function. You can write the expression also. Again, this you guys have been using from past few years. So -2, -1, 0, 1, 2, right? -1, 1, 3, 5 and 7, and you guys can imagine how all can this be used. So this is basically for understanding, visualization and representation and things, right? Tabulated form, you guys know, use it for drawing and everything. So yeah, then graphical form. So f of x is equal to x cube plus 3. I'm taking the domain -2 to 4. Graphical form is to do with drawing along your x and y axis, right? So let me generate this and show it to you guys. Let me talk about few things over there. So I have this code. We are talking about -5 to 5 actually. We will need, yeah, that will help us. So let me generate the graph. So that is our graph, right? Okay, so we have a visual representation of the function. Okay, so it has its own advantage, you guys know that, right? We will get to see the zeros of a function, if you guys remember the concept of zeros and values and all of that. Then we'll get to know the exact output, the range and the domain and all of that, right? So for this, say we have a domain of -2 to 4. So I can just do this. So domain, and what would be the range? So range will start off from here to this point. So basically it is something like this. Let me use a light color. Okay, and from here. So basically this space. So that's your range. So it's a very good way of representing the idea, and I'm going to use this a lot, right? That would be your domain and that would be your range. It's a very powerful tool, and please do make use of this, right? You guys, I mean, in the website, I'm sure you guys would have come across by now. So please see to that you yourself, just you have to alter a few things and you have the output, right? Then you get to look into the range and the domain and understand and answer better. So please make use of this, and the usage of graphical form and the lot plenty, right? So officially though I have not listed it and read it and listed it, so I don't want to tell anything wrong, but yeah, you guys can imagine the usage. Now implicit form. So y is equal to 2x plus 3. So as per the books, the implicit form is used when the equation is difficult or impossible to solve for one of the variables. So you going to write in this manner, implicit form, wherein we are not using f of x and all of that. Y is equal to 2x plus 3. So this representation is used when we are not able to solve for a variable. Okay, and this is your parametric form, wherein we have independent and the dependent variable related to another variable. So as per the books, this allows us to study the properties of the function and the relationship between the independent and dependent variable, right? Here t is your parameter and x and y are independent and dependent variables, right? So this is your dependent and this is your independent being related to another parameter. X and y are related, okay, just that they are related in a different manner. So y is equal to 2 times of t plus 3, while x is equal to t. Of course, when you substitute it over here, right, what happens in place of t, if I put x, so y is equal to 2x plus 3. It's the same equation. End of it, we are getting back the same equation. Again, this is a very simple example, right? That's why it looks, what is the use of this, when you get complex examples, when it comes to differentiation, integration, all of that, you guys get to know the power of parameter form. Okay guys, so it would be a good idea. Of course, you guys will not be seeing all of this in one place. It's not listed in your textbooks, but it's used, right? Directly or indirectly, it's been used. So I would like you guys to not miss anything. Write your own running notes. I've spoken of the usage. So people who are interested, please do make a running note all of that. Right guys, so if possible I'll make a PDF and put it across so that you guys can download if you're interested to know the exact usage that is listed in the books, not from my end, listed from the books, proper mathematicians listing the usage. Okay, now you can pause and have a look.